and it's like my head and the slides over on the side.
It can be. So how do you want to give it? And we'll
Yeah, so I would say,
I have some figures and stuff, so it may be good to see the slides in there as well. Unless you think just pointing it directly is fine.
the slides are all one separate thing, and then the picture's a separate thing. So it's like
see how it is? Here, let's look.
Okay. Oh, yeah. Perfect.
So,
Perfect.
this is going to be your head, and that's the slides.
Yeah, that's perfect. So if I point to stuff on the screen, is it going to show up there?
I mean, there's a way where we could, if you want to just sit down and use the mouse. That's the drawback.
Yeah.
We don't have like a handheld mouse.
Okay.
The pointer obviously does not translate.
Okay. Yeah.
So
I'll try to just describe. I'll try to just say.
because if you were given it live, we have more options here.
Yeah.
But in this case, I would just try to just stand over there, pretend like you're talking to the screen, like you're talking to the screen here.
Okay.
And if you don't move around too much, you don't have anything to do, I'll be happy.
Okay. I
want
will
to hear.
need to look at my notes
Yeah.
occasionally. So.
Of course,
Okay.
that just makes it better. No, but I'm just saying that that's part of you giving the talk anyway.
Yeah. Okay.
Just don't even think about it.
Okay.
It'll be fine.
All right.
Then you don't have to worry about interruptions.
Except all those hardball questions.
it's just that won't make any sense to you. You'll be like,
Okay.
So I've got. So this just allows you to stand here and use the answer forward back.
Okay. Okay.
Okay.
Perfect.
And then,
All right. So I think I'll just like set my notes on the edge of the table. Okay. So I can kind of have access to those.
we're-
Let me just hold them. Actually. Okay.
down just a little bit, sorry. I'm just going to get a little sound check to make sure that overloads on the sound. I'm going to get out of your way here.
Is this pretty good with turning heads and everything if I move my head around?
Yeah.
Okay, good.
Yeah, so I would stand for two reasons. That way you're not like don't have your head in the projector.
Yeah.
And then it just makes for
So that's not in the background.
yeah.
Okay.
So go ahead and just say a couple things.
Testing. 1, 2, 3. Sibilance.
Okay, go ahead.
Test. Unified Medical Language System, University of Michigan, Department of Computational Medicine. Is it, oh, it's not on.
That'll help.
There we go. Now it's on.
Okay, that's
There's
fine.
room mics that'll pick up some of it, so it's hard to tell.
Okay.
Okay, now go.
Test. Unified Medical Language System, University of Michigan.
Much better.
Okay, good.
Yeah, right there where you're at.
Where's the recording?
The recording's already being done. It's already done. Do anything. Just go, at the end, make sure you turn the recording off.
Okay.
So it'll keep running. If you just kill the thing, and keep going, so make sure the meeting stop recording.
Yep.
So just put this back in my room. Back that up. Headphones and mic.
Gotcha.
Back in the thingy. Cool. All right. Good luck.
Thank you.
It's a little funny. Sorry, man.
No,
It's
it's
my
all
fault.
good. It's all good.
This is my big speech for the last 2 days. Can't go back in time.
If
Time
only.
machines.
If only, right?
Can't be done. There isn't a version of you giving this talk from last month.
But what about
There
the
is
flux capacitor and the lightning bolt in 1984?
all what I call wishful thinking.
All right. Well, here goes.
All right.
Okay.
Have fun.
Thanks again.
You're welcome.
Yeah.
I'm just going to completely close this.
Okay.
That way
Cool.
nobody can access it.
All right. So ready to go?
Yes, sir.
Okay. I'm going to take just a second. Get psyched up.
Okay. Okay, thank you for the opportunity to present today. I'm Tyler Nix. I'm an informationist at the Taubman Health Sciences Library. And I'm going to present today an introduction to the National Library of Medicine's Unified Medical Language System. For just a little bit of context on my background and experience with the UMLS, I worked on a user survey at the National Library of Medicine a couple of years ago, but I'm not a programmer, so I may not be able to answer all of your technical questions. But I wanted to present on this from the context of it being a tool that you may find useful, excuse me, that you may find useful to use in your research. So today we will cover what is the UMLS. We'll kind of talk about the component parts and how it's organized and set up. We will look at a use case for the UMLS in information retrieval. We'll look at a related tool called MetaMap. That is a text mining tool that's based on the UMLS. We will look at some of the source ontologies that make up the content of the UMLS. And we'll talk about some access and licensing issues. And just to kind of give an overview, ontologies for today's context, we're just talking about basically any sort of terminology system that defines the way that knowledge is. God, I may have to start over. Sorry.
No problem.
Head trip. Okay.
Do you think it'd be easier if the room were full of people, or?
Yeah, because my instinct is to kind of look around. And then there's no one there, and I'm going hoarse. Okay. Or I may just do the whole thing. I may just stare at you the whole time.
Yeah, it's no problem.
Okay. Thank you for the opportunity to speak today. I'm Tyler Nix. I'm an informationist.
Want to start at your...
Thank you. All right. Thanks for the opportunity to present today. I'm Tyler Nix. I'm an informationist at the Taubman Health Sciences Library. To give you a little bit of context on my background with the UMLS, I worked on a user survey associated with the UMLS a couple of years ago. So I'm not a programmer. I may not be able to answer all of your technical questions, but I'm going to give you an overview of the National Library of Medicine's Unified Medical Language System as a tool from the context of a tool that you may find useful in your research applications. So we'll cover some basic information about the UMLS, what it is, what it's comprised of. We will look at a use case of the UMLS in information retrieval. We'll look at a related tool called MetaMap. We will look at some of the source ontologies that make up the UMLS. And we'll talk about some of the access and licensing issues with using the UMLS. And while we're still on this slide, I'll just take a moment to define, for today's talk at least, that we're going to be talking about ontologies as any sort of system that represents biomedical knowledge within a computer system. So basically, the Unified Medical Language System is a large database of existing biomedical ontologies that are brought together. And so that could include terminologies, control vocabularies, ontologies, and we're talking about terminologies like ICD-10-CM or SNOMED-CT or the medical subject headings, gene ontology. So these are kind of some of the examples of ontologies that exist within the UMLS, and we'll look at these in more detail as we go forward. So what is the Unified Medical Language System? Again, it's a set of database files and applications that integrates biomedical terms from hundreds of existing biomedical technologies. I'm just going to catch up on my notes here. So this is the homepage for the UMLS. The UMLS is kind of a conglomeration of database files and applications and tools. So this homepage is going to be your best starting point for finding the files themselves that make up the UMLS and the software, and also for any support and training documentation. Some of the common uses, it's often used as a term bank in natural language processing pipelines. It is used as a data annotation resource for custom ontology development, a match list for search engine retrieval, and for linking disparate databases and applications. And so to this last point, we're going to look at an example of how this sort of linking disparate databases actually works. So you see that UMLS is in the middle of this graph here, and basically it includes ontologies that are associated with very domain-specific databases. So some of the examples that we see are the OMIM ontology that's linked and used as the basic ontology for several genetic knowledge bases. It includes the medical subject headings, which is the control vocabulary that is used to index PubMed and clinicaltrials.gov. It includes gene ontology that you see in the bottom right corner there for genome annotations, and several others around. And so the way that the UMLS can help to link disparate databases and disparate information resources is that you could imagine if you were interested in certain records in OMIM or a gene database, you could search and find the affiliated indexing terms for those gene annotations or gene records, and then within the UMLS, map those over to medical subject headings so that would allow you to automate a search that would pull in, for example, related PubMed articles. So it's this idea of using ontologies from disparate databases to connect together through the UMLS. So how is the UMLS set up that it allows for this sort of connection to happen? The UMLS is really kind of a conglomeration of three different sets of files. So it's not one thing. It's the metathesaurus, which is where terms from hundreds of different control vocabularies are brought together. So it includes ontology concepts, terms, hierarchies, and relationships from several hundred existing biomedical ontologies. Then each one of those terms is assigned a semantic category. It's basically like saying a Ford Mustang is a car or edamame is food. Every single concept within the metathesaurus is also assigned kind of a broader semantic heading. There are also some lexical tools that are associated with the UMLS, but we're not going to cover those in depth today. So the metathesaurus has 14 million terms from about 200 biomedical ontologies. Again, we mentioned some of these that you may be familiar with already. The gene ontology, medical subject headings, SNOMED CT are just a few examples. And the metathesaurus is not just a static container for all of these vocabularies. It actually has some pretty powerful integration principles where it brings these terms together and links synonymous terms together at the concept level. So how does that work? The first of the integration principles is that synonymous terms are grouped as concepts. So what we're looking at here is a screenshot from the online metathesaurus browser. It's really just a way to access the metathesaurus online. Typically, if you were using it, it's middleware. It's not really intended for end user use, so you would usually be accessing these files through a relational database or in an application. But just for today's purposes, it's easy to kind of look at it this way. So what we see is a concept record for neurofibromatosis 2, which is a benign tumor of the inner ear. And we see in this concept record, we have the atoms expanded below the concept itself. So the concept has been given a unique identifier, the C0027A32. So it has a human and machine readable unique identifier at the concept level. And you see underneath, the atoms represent all of the ways that this concept has been represented across the 200 or so vocabularies within the UMLS. So we see in the brackets, there are several vocabularies, or there are several listings right here in the middle in the brackets that say ICD-10-CM. So ICD-10-CM represents the concept neurofibromatosis 2 as acoustic neurofibromatosis. So what UMLS is doing here is that for an end user or for a programmer, it would allow you to pull together synonymous terms that are used across multiple databases under one concept. Okay, so just to catch up on slides quickly, you see the concept at the top by the red arrow, synonyms for multiple ontologies down below, and we see in the highlight some of the potentially very different terms or very different ways that ontologies might represent the same concept. The second integration principle is that individual ontology hierarchies and term attributes are preserved. So not only is the UMLS pulling together synonymous concepts or synonymous terms, but as it does that, it maintains the provenance of the original vocabularies as well. So to see an example of that, we're back to our neurofibromatosis 2 record, and we see in the context tab down below, this is an example of how neurofibromatosis 2, again, is represented in ICD-10-CM, which is one sample ontology. And we see under the Ancestors tab, we see some of the, a snippet of the hierarchy of where that concept exists within ICD-10-CM. And we also see some of its sibling records within its own original hierarchy. So that's kind of the idea of bringing together synonymous terms while also maintaining the provenance of original sources as well. And that idea is represented here by this graph. So depending on what your use is for UMLS in terms of how granular or coarse you might need a particular set of terms to be in an application that you're developing, you can see how by creating one graph from these individual trees, you would have the option, theoretically, to use terms at a more granular level, like terms as A is related to H, or you could use terms in between in a much finer grained level with all of the steps there between A and H. And the third ontology integration principle is that relationships expressing meaning are recorded among concepts. Basically, this is saying that related terms are linked across concepts, and that might come from their individual vocabularies and ontologies, or these may be relationships between terms that have actually been manually added by metathesaurus editors or by kind of end users in concerted efforts to map certain vocabularies to one another. So again, back to our example of neurofibromatosis 2, to see an example of this, we see some of the concept relations, some of the other concepts within the UMLS that neurofibromatosis 2 is related to. And one to point out here that we'll see in an example here in just a minute is the NF2 gene. That's a tumor suppressor gene. So a mutation in the NF2 gene is related to developing this particular neoplasm. So some of the associative relationships that may exist in the UMLS, we see a couple here. They could be hierarchical, like penicillin is a more specific type of antibiotic, or they could be causal, like a bacterial infection is caused by a particular bacterium. And again, the example there with a tumor and a suppressor gene. So far we've been looking at how individual terms are related to each other across vocabularies and within vocabularies in the metathesaurus. But as I mentioned earlier, there's also this kind of additional layer of abstraction whereby all of the 3 million or so concepts within the UMLS are assigned to at least one semantic category. So in this case, neurofibromatosis 2 has been assigned as the semantic type neoplastic process. There are 133 semantic types. These are basically ways, these are entry points into the UMLS where terms are classed together by different meanings and categories. So using these semantic types in an application would allow you to, for example, pull all of the terms in the UMLS that are related to medical devices, access all the terms that are related to ideas or concepts, all terms that are neoplastic processes, etc. Not only are there semantic types, but these types are defined in several different relationship types, several different relationships to one another. So neoplastic process is related to the semantic type pathologic function with the relation type is A. There are hierarchical relationships, causal relationships. You see a few of the examples here on this slide. And so basically what this allows is it creates a network of meaning throughout the UMLS, and it allows you to extract concepts and build frameworks of entry terms or index terms that are based around certain meaning. And let me catch up with my notes very quickly. It also allows you, again, to pull large list of concept terms by category without having to know every single term within that category. Okay, so moving on. So this has all been pretty high level so far. We're going to start to put it together a little bit and see a couple of examples of how this actually gets used. So we're leading up to that, but just to quickly recap, the structure of the UMLS is to collect synonymous terms across multiple vocabularies. An example here would be heart attack, myocardial infarction, cardiac arrest, to extract the relationships that exist between concepts. And it also makes it possible to obtain a full set of concepts for a given category. So all of that is kind of summed up in this figure that we're going to take just a minute to walk through to hopefully bring all this home a little bit more. So we see in the middle terms are representative of UMLS concepts. We see neurofibromatosis 2 on the far left. We see a couple of its synonyms or its synonymous terms in the box there with it. The little swirly lines with the diamonds represent a relationship between concepts. So we see that it's related to the NF2 gene. And both of those are also related to this tumor suppressor protein called Merlin. So those are examples of what concepts would look like within the UMLS. Then on the top part of the slide, we see that each one of those concepts is assigned a semantic type. So neurofibromatosis 2 is a neoplastic process, NF2 is a gene, and Merlin is an amino acid. And then down below, in the bottom part of the diagram here, we can see how this sort of structure would allow linking across disparate resources. So from the Merlin record, the Merlin concept record within UMLS happens to have a unique identifier for its corresponding record in the gene ontology. So because that is already mapped into the UMLS, you could use a concept record to link out to GenBank and pull Drosophila studies that are related to this protein that you're interested in. And similarly with neurofibromatosis and linking directly out to OMIM. So this would allow you potentially, if you had, if you're working on a gene expression annotation, something like this could potentially allow you to expand the metadata associated with your annotation to potentially expand the use cases for that. And again, this is still somewhat high level. So we're going to take a moment to just look at a concrete use case here. I'm going to catch up in my notes. So this is, we're going to look at a team that has used the UMLS to enhance a search engine algorithm. And this is a study that was performed here at the University of Michigan, led by Dr. David Hanauer and several other people from across campus. So I'm going to give kind of a 30,000-foot view just so that we can look at specifically how the UMLS was used here. But if you have questions about the study, please do feel free to contact them. Basically, the problem that this team was was working on addressing was that clinicians and researchers don't always have time to create a perfect search string to search the electronic healthcare records over in Michigan Medicine. And the EHR search engine is called Immerse. So what they did was built an algorithm that uses UMLS terms through this tool called MetaMap, which we'll talk about in a minute, to identify medical concepts from the search queries. And then it maps those medical concepts back to the UMLS and leverages all of the synonyms that are available in the UMLS, as well as a set of synonyms that were developed here at the University of Michigan, to expand on that original search query. So this is a diagram of what the study looks like, kind of how the algorithm works. And you can see MetaMap and the UMLS being used in a couple stages of this study. So to build an initial index for this search algorithm, the researchers used MetaMap and the UMLS to extract biomedical terms from a set of EHR documents and to build basically an index out of all of those terms that were extracted from the EHR. And then down on the bottom left of the diagram, we see that, so the next phase would be that a researcher or a clinician at Michigan Medicine would come over to Immerse and put in their search query, and it might be something like patients with heart disease. They search for patients with heart disease. Running in the background, MetaMap and the UMLS would extract all the biomedical terms from that search query. And then those terms would be further kind of filtered using semantic types that are specifically targeted for clinical terms. And once the search was targeted to the most clinical terms, so in this example of putting in a search like patients with cardiac disease, the term cardiac disease would be isolated as a type of symptom. Then that term would be sent back to the UMLS to have synonyms and medical concepts and abbreviations and acronyms and all these kind of related extra terms appended to the search to make the search more powerful when it runs back through the index. So that's one use case, just an example to give you hopefully a little bit more of a concrete idea of how this could be used in practice. So because I mentioned MetaMap here as part of this study, we'll take just a moment to look at MetaMap a little bit more closely. Again, it's a very closely related tool to the UMLS. It's also developed by the NIH. And it is a tool that it basically retrieves and identifies UMLS terms from within free text samples. So we're looking at a view of the web-based tool. There's also a tool you can download to use locally and an API version as well. But basically the idea is you put in a sample of free text and MetaMap runs that free text and matches all of the biomedical terms that it can find to UMLS terms. So an example here, this is from a treatment guideline from the Endocrine Society. And we see just a brief text snippet here. It's some free text about glycemic control for pregnant women. And if we were to run that through MetaMap, what we see is that all of the potential biomedical phrases have been identified within this free text sample and mapped to UMLS concepts. So we see the phrase task force has been identified within the UMLS. We see in brackets the abbreviations for the ontologies where that term appears. And in parentheses, that's a mapping score, that's a strength score, basically how certain or how strong is this match from the free text to the vocabulary. So we see in the about 3/4 down, the meta mapping for women, we see that the term woman has been used in several vocabularies here, including mesh, AOD, SNOMED CT, and several others, and the same applies for diabetes and several other terms as well. So this may be a tool that you could combine with something like a term bank to start looking into natural language processing and text mining applications. So far we've talked about the UMLS overall, kind of very broad level, and how terms are pulled together into concepts. But we're going to take just a minute to talk about some of the individual ontologies that are housed within the UMLS, as they might be, again, of interest to your research. So gene ontology is useful for annotating gene products across various model organisms. It started out as the ontology that underlies Flybase and a few other databases, and is now used across a pretty wide range of gene-related databases and data sources. And you can get a better idea of what those are at geneontology.org. The NCI Hugo gene nomenclature, this is an ontology that includes a standardized gene name and symbol for every known human gene. It is organized by the HGNC, or the Gene Nomenclature Committee. And we have several others here. I won't go through the whole laundry list, but human phenotyping ontology is a vocabulary of phenotypic abnormalities. Again, the medical subject headings are used to index PubMed. And SNOMED CT and ICD-10 CM are both used heavily in the clinical environment. SNOMED CT is used for problem lists, and ICD-10 CM is used heavily for billing terminology for reporting and morbidity statistics. The UMLS is updated twice a year. The ontology selection, in terms of which ontologies are incorporated into the UMLS, it can kind of vary. So all the clinical terminologies and code sets that are designated by the federal government as standards, federal standards, will be included in the UMLS. And this is going to include ontologies and vocabularies that are used in the Consolidated Health Informatics Initiative, any of the HIPAA mandated terminologies, and also the Public Health Information Network Initiative terminologies. But NLM also works with other organizations to incorporate kind of more local ontologies. So if a research group has developed an ontology for their specific application, that may be incorporated into the UMLS as well. In terms of access, this homepage at the National Library of Medicine, which is part of the NIH, again, is going to be your best starting point. That's where you're going to be able to download the files and also get at some training and documentation and engage with the user community. We'll talk about this in a little bit more detail in just a minute, but well, I'll wait. We'll get to the licensing in just a minute. In terms of access options, it's typically you would want to download and install this to a relational database. There is an installer that will help you do that. You can also access UMLS content through an API. And you can also, if you just want to browse to get a better sense of how it works and what it is. There are a few web-based apps that we've been looking at so far, just as an intro today. The Metathesaurus browser, the Semantic Network browser, and MetaMap, again, are all available online. Here's a quick description of some of the file types and what you will find in terms of how those relate to connecting ontologies within the UMLS. If you're going to do a local download, you'll use this installer called Metamorphosis. This will allow you to create load scripts to pull subsets of the UMLS into your database or whatever application you're using. So most people typically don't code against the whole UMLS because it can really slow your application down. It can be very powerful to instead pull very specific subsets of the UMLS. So an example of that for a local installation might be that you only want to look at vocabularies that are in the UMLS that are in a certain language or that are free to use or from a specific vocabulary like gene ontology, or you only want to see SNOMED CT, or you only want to see mesh. And then you can also subset a local download by semantic type. So you could pull only terms that are clinical drugs or diseases and syndromes or bacterium, etc. In order to use the UMLS, it is free of charge in that the National Library of Medicine does not charge you to access or use the UMLS. But that being said, you will be required to sign a license, and you will be required to renew that license every year. And just some of the basics, I recommend that if you're going to use it, you read the license and the user agreements very carefully. But the overview is that there's no charge. It is for individual use, so there are no group or institutional licenses available. Some of the material, some of the ontologies and vocabularies are copyrighted, and so there may be there are specific restrictions on some of the individual vocabularies within the UMLS. A good tool to help you kind of parse out which ones you may want to use in an application or not, depending on their licensing. There is this vocabulary documentation page. Each of the licenses are divided into 9 categories. So you can search by ontology, vocabulary terminology, or you can search by the category to determine which ontologies you may want to use that fit your particular use case the best. Just a couple of quick examples. Category 0 are free to use and distribute. So you could potentially build an application and use Category 0 terms, ontologies within that application. If you were using Category 3 or some of the other categories, there would be more strict limits in terms of how you could potentially distribute or use that application more widely beyond just local research purposes. And the kind of history behind the licensing is that when the UMLS was first developed in the late 1980s, it was very common for institutions to have licenses to ontologies at the institutional level. And the idea was that the UMLS was software that would allow those different ontologies to talk to each other. But institutions at that time were more likely to have an institutional agreement or a license that was kind of more localized and more restricted to local use. At any rate, we recommend that you review this pretty carefully, and we're happy to. I'm happy to consult with you or meet with you, talk to you further about specific use cases in terms of how they relate to the licenses. So with that, I'll take any questions, and thanks again for your time. Gosh.
How you did good.
That was painful.
You're a little stiff in the beginning.
Yeah. It'll work. It'll work. Well, thank you again for pitching in and taking some time.
Oh, yeah.
I appreciate it. So it's